For decades, we've imagined a future where machines think. That future is now, but it's not quite what we expected, is it? Artificial intelligence isn't just used in labs or by tech giants anymore. It's in your pocket, your home, and even your workplace. And if you're thinking, I'm too old for this, think again. Because the truth is, your experience is the key to harnessing AI's true potential. And frankly, AI isn't going anywhere. Because this is a foundation series, I wanted this first video to give you a basic understanding of AI itself. However, as I reviewed what I wanted to cover, it was too much for one sitting, so I decided to split it up into two separate parts. This video will explain some foundational concepts, and the second will cover terminology, potential challenges, and ethical considerations. It may not sound like much for a single video, but I don't want to make any assumptions about how much you know. I feel like it's better to take a bit longer and ensure that everybody has at least some understanding and exposure to these things before I use them frequently in future videos.
Excuse me, sir. Seeing as how the VP is such a VIP, shouldn't we keep the PC on the QT? Because if it leaks to the VC, you can end up in MIA, and then we'd all be put on KP.
Terminology can be confusing. So what exactly is artificial intelligence, or AI? Well, it's kind of like we're teaching computers to think and learn just like we do. We learn from experience, AI systems learn from data. Lots and lots of data. AI is already in your pocket. When your phone recognizes your face or suggests the next word in a text message or gives you directions, that's AI in action. But AI isn't just about cool gadgets, it's redefining industries. In healthcare, AI can spot disease in scans faster than human doctors. In finance, it can detect fraud in the blink of an eye. Now, you might be wondering if AI is going to take our jobs. The truth is, it will, at least some of them. AI is changing how we work, but it's not all about replacement, it's about enhancement, and that's where your experience comes in. Think of AI as a super-powered assistant. It can handle repetitive tasks, process huge amounts of data, and spot patterns that we might miss. But this frees us up to focus on what humans do best: creativity, empathy, complex problem solving. In every field, from education to management to design, AI tools are emerging to make our work easier and more effective. And it's happening faster than you think. But here's the key. AI is powerful, but it's not all-knowing. It needs human guidance. Your years of experience, your intuition, your understanding of people, these are all things that AI can't replicate. That's why no matter how old you are or what your background is, your role in the AI revolution is crucial. You've got the wisdom to ask the right questions, you can apply AI's insights in the real world, and ensure that this technology responsibly serves everybody's needs. We're stepping into a new era where human intelligence and artificial intelligence work hand in hand. And guess what? You're not just along for the ride, you're in the driver's seat. So let's dive into some cool stuff, the key concepts that make AI tick. Don't worry, I'll try and keep it simple and fun, like a root canal. I want to start with machine learning. Imagine you've got a robot, like your personal C-3PO, and it's learning to sort your Halloween candy. You start by showing it lots of different candies and telling it which ones you like and don't like. It observes each piece of candy, noticing things like color, shape, and wrapper text. Eventually, the robot starts to notice patterns. For example, you seem to like round or colorful candy, things with fruit names on the wrapper. Now, when Halloween comes, you give the robot a new piece of candy, and it looks at the features and tries to guess whether you like it or not. If the robot guesses wrong, you tell it, and it uses this information to improve its guesses next time. That's basically what machine learning does, but with data instead of candy. We feed computers tons of data, and they learn to make decisions or predictions. The more data we give, the smarter they get. It obviously goes much deeper than that, but if you understand that basic concept, then you've got a clear enough picture to start adding other concepts to the mix. A few quick examples of machine learning that we already see are how Netflix knows what shows you like, how your email catches spam, or how a weather app predicts if you'll need an umbrella or not. Once you understand machine learning, you can go one step deeper, and that's where we come to neural networks. These are the superheroes of AI, and they were inspired by our own brains. Think of a neural network like a team of students working together on a big jigsaw puzzle. Each student is like a neuron in the network. On their own, they can only solve a small part of the puzzle, but when they work together and share information, they can solve complex puzzles that no single student could tackle alone. As they practice, they each learn what pieces of information are important. They get better at passing useful clues to one another. Maybe one student takes the edges, another takes shapes or colors in the puzzle. The whole team becomes smarter and faster at solving puzzles because each neuron gets really good at its particular job. Now, just like this team, a neural network combines simple parts or neurons to solve difficult problems. It learns from experience, and over time, its performance improves. By doing this process over and over, neural networks can handle complex tasks that individual parts or neurons couldn't manage alone. For example, when your phone recognizes your face, it's using a neural network. Each neuron might detect something simple like an edge on one of your features or part of the shape of your eyes or even colors. But together they can say, yeah, that's definitely Karen or Chad. Now, if neural networks represent heroes, then deep learning is like the Justice League of AI. Now, hear me out. Imagine building with Lego bricks. A single layer of bricks can make simple shapes, but when you put multiple layers together, you can create intricate structures like castles or spaceships. That's how deep learning works. It's like stacking several neural networks together. Each layer does something unique, kind of like a superhero's signature power. The first might outline all of the edges in the image. The next might identify independent shapes. Deeper layers could recognize entire objects. We call it deep because it uses multiple layers of neural networks to grasp increasingly complex patterns, just like how you understand the world through multiple levels of thinking. This approach allows AI to complete tasks that once seemed impossible for machines. It enables machines to understand speech, recognize faces in photos, and even make decisions when driving cars. Deep learning image recognition is used in medical diagnostics. It can analyze images like X-rays or MRIs to detect diseases. For example, they can identify potential cancerous tumors in mammograms with incredible accuracy. Google Translate uses deep learning to return more context-aware translations by learning nuances and idiomatic expressions from long-form conversations. This is far more complex than just responding with, "Where's the bathroom?" in a different language. And that leads us to natural language processing, or NLP. It's the technology that enables computers to understand and interact with human language. It reads, writes, and can even understand sarcasm, sometimes. But in fairness, my wife still has trouble with that. NLP is already in so many everyday tools and services. Virtual assistants like Siri, Alexa, or Google Translate. It's doing sentiment analysis in social media monitoring, text summarization for long documents, chatbots for customer service, content generation for articles, and advanced grammar checkers. But when we put it all together, we notice a pattern that AI applications often combine multiple technologies. Smart home assistants integrate machine learning for habit recognition, neural networks for voice processing, deep learning for decision making, and NLP for communicating with us. The future isn't AI versus humans, but rather AI and humans collaborating. By combining human experience with AI capabilities, we can accomplish and create so many things. And creation brings us to generative AI. This is the technology behind AI art generators you might have heard of, like Midjourney or DALL-E, or chatbots like ChatGPT or Claude. Generative AI can create new content, stories, images, even music, and it looks and sounds like it was made by humans. GPT is probably the most popular type of generative AI you've heard of. It's the magic behind chatbots like ChatGPT. It's literally in the name. But don't worry about the technical details of GPT. Just think of it as an AI that's really good at understanding and generating human-like text. It works by learning patterns from vast amounts of existing data and using those patterns to create new original content. It's like an AI chef who studied thousands of recipes and exactly what ingredients complement one another, as well as the best way to prepare them. With that information, it can create brand new dishes that taste great. This technology is exciting, but it does raise some ethical questions about creativity, copyright, and the nature of art. It's a hot topic in AI ethics discussions today. Lastly, let's touch on transfer learning. This is similar to how humans use their existing knowledge to learn new things faster. If you can dodge a wrench, you can dodge a ball.
If you can dodge a wrench, you can dodge a ball. What?
In transfer learning, an AI model is first trained on a large general task. Then this pre-trained model is fine-tuned on a more specific task. For example, a chef who's mastered French cuisine might find it easier to learn Italian cooking than somebody who's starting from scratch. This approach saves time and resources and often leads to better performance, especially when we don't have a lot of data for the new task. For example, a model trained to recognize objects and images might be fine-tuned to detect specific medical conditions in X-rays, even if we only have a small number of X-ray images to work with. Now, these last two concepts, generative AI and transfer learning, they're part of what's pushing the boundaries of AI possibilities right now. They're behind many of the exciting AI applications we see, from personalized recommendations to AI-generated art and more efficient medical diagnostics. Now, we've covered a lot of ground here, and you might be thinking, I can't remember it all. You're going too fast. And you're absolutely right. That's actually why I decided to stop here and move the rest of the topics into another video. Don't worry if you don't remember everything. In future videos, we'll review these topics again and dive deeper while exploring more specific AI models and technologies. I promise it will start to make more sense, especially when we get to the hands-on stuff. But by explaining a number of these concepts right now, your brain can start making its own connections as we discuss other ideas. And once you start making that type of progress, you're on your way to truly learning about AI rather than just hearing about it. But for now, let's move on to the next video.